Hey everyone. This is Jason Key at SB Grid at Harvard Medical School in Boston. Thanks for joining us today. First, I want to do a couple of announcements. Upcoming webinars, we've got them up here on the slide. We've got back-to-back webinars with Willy Riggers. We're going to do Citus and Sculptor. So that's going to be back-to-back Willy Riggers show. It should be great. And then following that, we've got XMDFF, which is a flexible, free-fitting molecular dynamics tool written by Abhishek Roy. Abhishek's in Champaign-Urbana, and this is it's a very cool piece of software. It's very cool to see molecular dynamics at work, fitting electron density, which is sort of very cool to see. He showed this off at our workshop earlier this year, and it was pretty impressive. So I'm looking forward to that. So one other announcement. So today we'll be talking about PyMol. So I just wanted to take a minute to announce that SB Grid is now officially hosting the PyMol wiki. So Jason Vertrees reached out to us, and we were happy to take over. I would like to thank Jason for, I think he put about 10 years of work and a lot of blood, sweat, and code into PyMol. So thank you very much, Jason, for that. And it is in good hands. And so with that, I'd like to turn it over to Daniel Capel. Daniel's joining us from Schrodinger today. He's a senior application scientist at Schrodinger, and he's going to be talking to us about communicating your results with PyMol. So Daniel, are you there?
Hello, everyone. Thanks a lot for spending your lunch today with me. I'm feeling honored about that. And as you said, I'm going to talk a bit about some nice functionality in PyMol on presenting research results. Before I actually dive into the software, let me quickly give you an overview about what you can expect today. First of all, I'm giving a quick introduction to PyMol for someone who's new to it, so you don't have to start with any previous knowledge today, but if you have, you get a quick refresher on that. We will set up some nice visualizations. We will look at animations in PyMol and also render a movie using PyMol. We will plug that into a PowerPoint presentation, and we have time for general tips and tricks. I'm very happy to answer questions, so please feel free to ask and make notes of things which are unclear, and let me know if something is too fast or too slow over the transmission over web, because I'm hosting that here from Germany. As was just mentioned, there are very good resources on the web on getting help on PyMol, and one of them is the PyMol wiki. I summarized a bunch of links here on that site. First of all, if you go to pymol.org, you can directly get the precompiled binaries for this open source tool from there. But you can also get the source code on the SourceForge site for PyMol. Help you can get from the PyMol mailing list, which is hosted. You can subscribe to that or look up old contributions. And there's this really great PyMol wiki, which I would recommend everyone to take a look at, because it contains a variety of documentation, but also scripts and plugins which were written by the community over the last couple of years. There's also a Doku wiki hosted by Schrodinger, which has basically some training material, videos, and also a list of new features coming out with the different versions. And finally, if you have trouble with something, you can always contact Schrodinger on their support site. So that's basically the introduction. Yeah, again, if you haven't seen the different pages, this is this internal Schrodinger page. You can look at the different versions and new features, and really recommend it. Sorry, this is the wrong page. The PyMol wiki, which I would like everyone to. Now Google wants me to ask something. Sorry. If you go to the PyMol wiki, you find a lot of plugins, scripts, and so on, and we will come to that a bit later. I hope everyone can see everything fine. I'm going to open PyMol. PyMol is a software which runs on Linux, Mac, and Windows. in the same way. If you open it, you get two windows. One is the control window, which has the option to type in commands, a few buttons, and the menu. And then you have one window with a black background, which is used for the molecular visualization. If you happen to use a Mac, then both windows will be combined to one larger GUI. Pymol reads a variety of different file formats, up from PDB over XYZ files, SD files, MOL file, Maestro files, MOE files, electron densities in different formats. So you can load them directly here. And let me just start by opening a PDB structure. This is the factor 10A structure. If you open that into Pymol, you see it shows up in that black area. And whenever you load a structure, you will also get an additional entry in this table here on the right-hand side. And this table is useful because it allows you to show and hide a particular structure by just clicking on the name of the structure. So if I click here, I can hide and show that particular structure. And next to it, you have the buttons ASHLC, and they allow you to control the visualization of that particular molecule. If you click on C, you can control the color. For example, I like to have my structure in pink, then I can change that here. Or I would like to have it in olive, or I would like to color it by element, but with blue carbon atoms. I can control that from that menu. Then L stands for label. For example, I could label all chains. So this is a structure consisting of two chains. So you see that all the different molecules get a label by chain. For example, there's a metal over here. It is chain A, but also the chain itself. With hide, I can hide something. For example, I can hide the labels, but I can also say I want to hide the non-bonded atoms. In that case, that are the water molecules, which are shown by this little red X. So if I do that, you see they disappear and are no longer visible. If I want to show something, I can use the S menu. S stands for show. So for example, I say I want to show, in addition to the wireframe representation, I also want to show the cartoon of that structure with helices, sheets, and loops. I can do that with the S menu. And finally, A stands for action, which allows you to do a couple of different things. For example, I can zoom to that structure if I happen to move it somewhere far away, which you can do with your mouse. Then I can go for action zoom, and it will zoom back to my visible screen area. That's useful. But there are many more, and I will touch based on some of them over the course of that training session. I mentioned you can move your structure with a mouse. So the left mouse button is used for rotation. The middle mouse or pressing the wheel will translate the structure, and the right mouse button will zoom in and out. In addition to rotating the structure that way, there's also something called, actually I forgot the name, but just place your mouse somewhere in the black area around the structure, and then left click with your mouse. And if you then rotate, you see I'm rotating around the axis which is coming out of the screen. If I would have to do such a rotation in the classical way, it would mean that I have to do many individual steps to rotate the structure, and therefore we have this additional mode. If you do not like it, you can actually turn it off. And now remember, it's called virtual trackball. It's here in the menu. If I click on that, then a rotation from the black area will continue to rotate in the axis in our display. And if I, just for comparison, turn it on again, then the rotation is in the axis coming out of my screen. So I think that's pretty useful. Let's zoom in. One more thing you can do with your mouse, you can just single click on your wheel and have the mouse over a particular residue at that time. And that means I'm actually putting the center and focus of my visualization on that particular atom. So I'm going to rotate then around that particular atom, and it will basically also it will zoom to that place and focus my visualization. And that's useful if you have, for example, X-ray electron density, you want to navigate along the backbone to inspect the structure, or so you can walk around that. So that's a quick overview about how PyMol behaves. If you happen to forget what your mouse did, on the lower right-hand corner, you have a quick description on what the mouse buttons do: left rotation, move, and right move in Z direction. But you also have combinations with control shift, and so on, where you can do multiple things. And this is not only a help, but it's also interactive. So at the moment, for example, it says selecting residues. And I'm going to select something in PyMol by just left clicking on that particular, on a particular atom. And you see at the moment I'm selecting whole residues. Let me just maybe select something which is a bit clearer to see. So let's select that one here. So I'm left clicking on that. I'm going to select the whole residue, but I can also click here on selecting. And if I click on that again, now it's set to chain. If I now click on an atom, it's going to select the whole chain. I can change that again to segments, objects, molecules, C alphas, or individual atoms. So if I want to do that, I can only select individual atoms. And as you can see, clicking on multiple atoms, PyMol automatically adds these atoms to the selection. And if I want to get rid of my selection, I just have to click somewhere in the black area. I can do that again and click on a few atoms. Let's switch that back to residue, select the whole residue. Once I have selected something, a new entry here on the right-hand side in the table shows up, which is an abbreviation for selection. And now I can do the same thing as with the whole structure. I can change color, label, and so on. For example, I'd like to color that particular residue red because I want to highlight it. And I maybe want to show sticks and make it a bit thicker. And I can do it like that. So these selections are very powerful in order to control your visualization. And if you want to keep a particular selection, you have to basically give it a unique name, because every new selection you create in PyMol will automatically get this default name. And in order to save a particular selection, we rename it. And that's what we can do over the action menu. You can go to action, and then where is it? Rename selection. Oh, it's at the top. Sorry. You get a dialog here. Selection is going to get renamed to, well, let's call it one residue. You see now you have a new selection. You can deactivate it, then you don't see the markers here. And when you now start selecting something else, PyMol will create an additional selection. And that is very useful in order to generate a nice representation of your structure. So let's get started, and let's do something. I'm going to delete all of that and actually going to use a preset. Sorry, I'm going to show that to you again, pre-for default. Okay, so I'm going to zoom out. So this is my whole protein structure, and what I would like to do is I would like to look at the binding site and zoom in maybe and inspect some things there. So let's do that, and I'm going to combine that with a concept called scenes, which is very useful if you have multiple visualizations of the same structure, you want to save them and discuss with a colleague. So let's first say I'm going to save a scene based on the whole protein structure we are seeing here. I can do that with the scene menu. You go to scene, append, and it will add a new scene. It's like a scene in a movie. You see it gets the name number 1. Now we are going to locate the binding site, and you can do that by finding it yourself. You can use the sequence viewer and navigate to a whatever particular residue and zoom to that residue. Or you can, for example, let Pymol automatically find organic molecules. You can go to Action, Generate, Selection, and select all organic molecules. So let's zoom out again. You see it has selected all organic molecules. You can show them in different way, and then it's easy to spot where the binding site is. And that's with this particular co-crystallized ligand molecule. So let's say we have located the binding site, and we are going to append a new scene so that we remember where it was. And now the strength of Pymol is when you share these results with someone else, you have these two scenes, and Pymol can interpolate between the two scenes without losing track where you are. And it's very easy to remember different parts of your structure and annotate them with something. For example, we could rename the first scene here and call it full protein. The second one we will call binding site. And now let's say, okay, we want to change a bit the visualization of that second scene here. We can create yet another scene and use a function called preset, which makes it very easy to generate different types of visualization. So what we're currently seeing is the default, but there's something, for example, called simple, which will just render the backbone and show non-bonded or organic molecules in sticks or with these stars. But we could also use technical. It will also show all polar interactions in the structure. Or we could use publication, and that will show you the cartoon representation with helix sheets and loops plus the binding site. I like that one, so let's keep that one for our third scene. So we have the full protein, we zoom to the binding site, and we have the binding site in a maybe different orientation. And now let's create our last scene and, for example, say we want to show the surface in addition to the cartoon representation. How can we do that? We can easily show the surface for the whole structure. If I click on that button, you see now I'm getting the surface for the whole protein, but that's probably not what we want. So let's hide that again. I just want to see the surface for the binding site, and that's where selections are very useful. So I can select my ligand molecule, and now I can tell Pymol to select everything in a certain radius around that molecule. And I can do that here via Action, Modify, and I want to select everything which is around residues within 5 angstrom. You see now these residues get selected, and then I can say, please show me the surface for these residues. We could give the selection a name, and okay, so now we have the binding site. Now maybe we don't like the color. We could in principle change the whole color of the structure, and for example say we want to color it by secondary structure. You see that the loops get green color, sheets yellow, and helix is red, and that this binding site doesn't have any helical contribution. That could be a possibility for our whole structure, but maybe we'd still like to see the binding site in a different way. So let's do that. And for that, we have control over all kind of visualization using settings in Pymol. And then there are really many settings. I come to that a little bit later. And some of them are exposed here in the menu, not all of them. Many are just exposed via command line or a particular dialog I'm going to show you. But for the surface color, it's under Settings, Surface Color. There are a few default color, a few suggestions. The default one that the surface color is the same as the atom color. But for example, I can say I'd like to have the surface in gray, and the rest of the protein is still colored the same. And I can actually even change the transparency of the surface to, let's say, like 40%. You see now it's a little bit transparent. I hope you can see that over the transmission. So I'm going to finally save a last scene. And now we have basically everything in PyMol we would like to show a particular colleague. So we can save our whole work in a so-called PyMol session. You go to File, Save Session, and I give it a descriptive name, call it training. And when you open PyMol the next time, you will get exactly the same setup. You have all your scenes, and you can discuss your research results with a colleague and have a few annotated views of your molecular structures. I hope everything is clear so far. If not, please speak up and ask your questions. Otherwise, I'm going to continue. If you have these scenes, it is now very easy to use them to save images, but also to generate a movie and an animation. You already seen that PyMol can interpolate excellently between these different scenes. And now let's assume you need to embed your results into a PowerPoint presentation, into a publication, whatever. So there are different ways of getting data out of PyMol. Of course, you can export structural data by saving molecules, but I'm talking about saving the visualizations. First of all, you can save images. If you go to File, Save Image As, you can save it either in formats which are understood by different rendering engines, but you can also directly save it as a PNG file. Let me just do that and call it image number 1. PyMol is going to save basically what is in that screen here. So my desktop now has an image, and you can see I'm actually seeing exactly what was on the screen. But you also have the ability to generate higher quality images. So you, for example, see there is some not so soft edges of your molecular visualization, or we can improve that in PyMol, but with a few settings. But you can basically ray trace an image by using this ray trace button here, ray. If you click that, it a few seconds, and PyMol will render an image based on what you're seeing here with higher quality. And now hopefully you can see that that this image has smooth edges, and it also added additional shadows. The moment I'm going to move something, this information is lost, and you have to do it again. Click on Ray again. Let's wait a second again. So now you see, hopefully, this nicer image. You can also then go to save image as PNG, and let's save it as image number 2. The other thing, at the moment, the size of the image is the size of the actual PyMol window. Maybe you want to have it bigger, you can resize your window, or you can give a few arguments to the command ray. And for that, now we have to use the command line in PyMol. And that is really, really powerful because it embeds also Python. So you can write whole scripts which automate your tasks. And you will find many examples on the PyMol wiki, which we discussed earlier. So let's simply start with this ray tracing command. In order to type in a command, you can type it over here, or you can type it at the bottom in this other window, whatever you prefer. And if you don't know how the particular syntax is, you can always type help and then the name of a command, and you will get a description. For example, for the command ray tracing, it's called ray. You see a full help message shows up here. And it shows that you can also specify the dimensions of your figure. So for example, I can say ray and then 1,200, oops, sorry. Let's need to switch back to the scene. I can type 1,200 times 800, and it will now ray trace the image with exactly the amount of pixels. So if I do that, it's slightly larger. It will take a second longer because I'm doing that here from a Windows laptop. hold on for a second. Now you see the image in that dimension has been rendered, and you can save it afterwards. So that's very useful to get image of a particular size. And now you can go one more step ahead. There's a command called image, which takes several arguments. Let's again see how that goes by typing help image. Sorry, the command isn't called image, it's called PNG, sorry. If you type help PNG, you get a description of that. It takes several arguments. PNG, the file name, so it's basically the same as file save image, but you can also specify directly here the size, the dots per inch. So journals you typically require 300 dots per inch, but for a PowerPoint presentation, 72 is fine too. And you can say it should be ray tracing. So everything we have done in individual steps can be one command. So let's call it image 3.png. Dimension should be 1200 times 840. I want to do it with 300 dpi, and I'd like PyMol to do the ray tracing. And then with one command, you're going to save the image in that size with this, and that was going to get saved in my let's wait for it to finish. You see this image shows up, and you have that here. A few more tweaks. You can control the background color in PyMol under settings. Under display background, you can say it should be white, or it should be gray, light gray, or you can untoggle opaque. If we do that, the image we are going to ray trace will have a transparent background, and that is in particular if you embed something in a presentation, or you have to combine multiple images, that the background is not overlapping with another graphics you have here. And it's indicated here in PyMol with this chessboard that this is a transparent background. So that's also possible to do. If we want to get a bit more fancy, then we can actually set even a gradient as the background. And the command for that is basically we have to set a particular variable to on or off. And in order to set a setting, the command is called set. And the parameter we're going to adjust is the BG, the background gradient. And if I set that, now you see I'm having a dark blue to light blue gradient in the background. I can do that here over the command line, or I can use this very useful setting dialog under setting, edit all. All settings which are available in PyMol show up in a huge list, and you can search for something. So let's start search for everything starting with BG for background. You get all these settings, you hover your mouse over it, you get a short description at the bottom what this setting is doing, and we just turned on this background gradient. I can turn it off or on here as well. I can actually specify a full file name if I like. So for example, let me do that here, because then it's easier to type that image file name. PyMol understands auto completion by tapping. So I have PyMol bootcamp and have a background example. So I created an image with a logo, and you can set that as PyMol background if you like, for example. And you can control, if you have a gradient, the colors at bottom and top by RGB codes here, and set any color you like. The same here for if you have a plain one color background. So you have the full control about how your images should look like with these settings. And keep in mind, all the other settings in PyMol are available from here as well. So this is a great list. If you don't know how to adjust something, just search and look at the help messages down here.
Daniel, could I interject a question here?
Absolutely.
User asked how to deal with shadows, how to add shadows, how to get rid of shadows. Could you say a little bit about how shadows work?
Absolutely. That's a very good question. So we have seen when we ray automatically shadows get added. Let me quickly do that. Okay, maybe it's more visible if I change it to black and unset BG gradient. Okay, so if I ray trace, I'm going to get shadows automatically added. That's the default setting. Personally, if you ask me, I don't like them because I find it distracting from the original molecule. So there's a setting to disable shadows. And if we just search for shadow, it's called ray shadow. If I untoggle that and do the ray tracing again, you will see this time that no shadows get added to my image. So that's a way of disabling them completely. Now, if you like shadows and want to keep them, but you want to control where the light source is coming from, there's a way to do that in PyMol as well. This menu on the lower right corner, it not only allows you to change what you're selecting, you can also switch between different mouse modes. The default one is viewing. If you click here, you go to editing. But there's also a mode to change the light. Actually, it's not available from here. I'm sorry for the mistake. You have to do that over the menu mouse. You can go to 3-button lights. I think you can go to 3-button lights. It's actually not working. That's an, I think we run into a bug. Let me quickly try that again. Okay, now it worked. Something, I misclicked something. Okay, if you go to mouse 3-button lights, you see the mouse mode changes to 3-button lights. And now if you shift left click or middle right, you can shift. I do that, press shift on my keyboard, move the mouse. You can control from where the light is coming in PyMol. And if you then ray trace, of course, the shadows will be in a different direction because it is coming from a different end. I hope that answered that question. Any additional questions at that point?
All right, I think we're good. Go ahead.
Okay, good, go ahead. So we have saved now a static image. We can embed that anywhere we like. But what about having something not so static embedded into any other program or a document? There are multiple ways of doing that. First of all, we can embed the whole PyMol session in a PowerPoint presentation. So I have saved that session previously on in my documents directory. And if I switch back to PyMol and let me just start from scratch and create a new presentation. I have installed a plugin called ActiveX PyMol that's available from the Schrödinger website. It's not an open source tool. If you install that, the full version, you have the ability to create PowerPoint presentations with PyMol embedded. If you want to view it, you just need to install the free reader, which is available for everyone. Anyway, if you have installed it and you have an additional menu in PowerPoint called add-ins, and then you can insert ActiveX PyMol. And if you click on that, you can draw a frame. And in that space, the PyMol session will become embedded. And then if you have done that, you have to specify the file which should be there. It understands PyMol sessions, but also directly PDB or Maestro files. I'm going to use the training session we created before. You can embed your PyMol session with a PowerPoint file so that you don't need to send along the PyMol session when you share the presentation with someone else. And you can control if all the PyMol controls will be hidden or not. I'm going to show you the effect in a second. So let me quickly do that. And now I go into the presentation mode, and it will take a couple of seconds. And then basically PyMol is loaded from within PowerPoint, and you have full control. If you're in a meeting, you can interactively explore the structure. You have access to all the scenes. You can actually change even the visualization here if you like that. The only thing you can't do is save the results to disk again. So that was the version with the full control. Now let's create a new slide and insert PowerPoint here again. This time I'm picking the same file, but this time I say, please hide all the controls. If you do that and start that one, you see now PyMol shows up without controls on the right-hand side. You can still interact with it, but it's a much cleaner look than before. I'm still having the sequence viewer on here when I save the session. So if you don't have that on when you save it, it will be just the black area and you can show a molecule. So that's a way of getting an animated view of your molecules into a document you can share or present. That's one way of using PyMol for that. How we're going to say that. The other way now would be that we generate the animation in PyMol itself and save it as a movie file. And what we have done already so far is creating an animation. So we have defined several scenes of a movie, and we can simply use that, and PyMol can generate an MPEG or a QuickTime movie from that. So how are we going to do that? The easiest way is really to set up different scenes of what you want to show, and then you go to the movie menu, and there are predefined programs. That's the second menu item here. And one of them would be, it's called scene loop. So I'm using the scenes I'm already having, I'm looping through them, and for each scene I can define what should happen with my camera. It could mutate a little bit at the position it is, it could rock around in X direction or Y direction, or it could be steady. So let's take mutate. I can define how many degrees and how long it should stop for each scene. So let's say 60 degrees over 4 seconds. If I click that, PyMol will automatically program the movie very quickly. And this little blue bar at the bottom of PyMol shows up. And that's basically defining the plot of the movie. And now I can use the play button here in PyMol to view my full animation. So you see the camera is mutating, and then it zooms over to the second scene. The camera mutates again a little bit to get the depth. It goes to the third scene, mutates a little bit, goes to the last scene, mutates, and zooms out and starts from the beginning. And now this will loop if I don't stop it. So that's all I have to do to generate a movie. And now I can very quickly export the movie as an MPEG here under Windows. If you have the Mac version, you will save a QuickTime movie. So save movie as MPEG. You can control the quality. 90, I think, is a good default value. You can control how big the movie should be. This is the default resolution here. And you can say if it should ray trace the frames. We have gone through this ray tracing exercise before. You know that the quality gets better, you can get the shadows. If I toggle that on here, each of the individual 750 images is going to get ray traced, and PyMol afterwards combined it to a movie. I'm not going to do that for this training here for the sake of time. I'm just clicking on OK, and I'm specifying it with a name. And now you see PyMol goes through all the images, makes screenshots, and saves that, and then combines the movie. I have prepared that previously. Let me quickly show you how that looks like. So I have this MPEG file. I generated a similar session before. And you get such a movie, which you can embed anywhere you like. Okay, so that's what you would get out. And we get something similar out from our session here as well once that is finished. So let's hold on for a little bit, should be done soon. And don't close PyMol before it actually says it has finished, because it's still writing a lot of temporary files and it's still combining them now to produce the video. So unless it says finished, don't close it. Otherwise your work with generating the movie is lost. And if you ray trace that with individual frames, it takes a little bit longer. So let's see what we have done. Should be done soon. Okay. Anyway, we could continue to wait, but you have seen how the movie looks like. What I would like to show you, we did now that the easiest way to set up a movie is using scenes and automatically let PyMol generate the program. But what if I like to have some more sophisticated control and maybe make individual scenes last a little bit longer and others a bit shorter? I can do that as well. Oh, the movie generation just finished. I think I saved it on the desktop. Yeah, here on the desktop, we see the movie we generated, and we can play it in any movie player. Okay, so now how do I do the movie setup if I want full control about what is going to happen? For that, let's reset my movie so that I start from scratch. I still have my scenes because they control how things look like. And now we can say we generate a Planck movie for a certain number of seconds. So let's say we generate a 12 seconds long movie by movie append number of seconds. If I now play that, nothing is going to happen. Looks very boring, just shows the initial structure. And we maybe want to show the structure at the beginning. So what we can do, we can place this little gray cursor at the beginning, right click and say at the beginning, please store that frame with this scene here, full protein. And then after some time, let's move the cursor to a different position. We say we want to store it with scene number 2, the binding site. We want to stay here for some time, store it also with scene number 2. After some more time later, we would like to store it with scene number 3. And that should also last for some time until here, store with scene number 3. And finally, at the end of the movie, I want to be back at the beginning, so we're going to store that with the first scene. So now if I now play the movie, you see I'm going to zoom into the site, I see the ligand, I zoom out to the other scene, stay there for a moment, and then go back to the beginning. That may be useful if you really want to explain something in a presentation and the movie should pause at a particular view and you want to explain something. We did that now initially. Maybe we are not happy. I think the initial part here, I need more time to explain what I want to explain. So I want to make that longer. That's easy to do. You can press Control on your keyboard. And if you move your mouse from left to right, then you see it's getting green. You're adding additional time at that position. And you can make the time here much longer. So now let's play. So it remains much longer in that view before it goes over to the next one. So now my movie overall got more frames, but that's fine. Now it maybe made it a bit too long. If I press Control and go from right to left, you see it's getting red. I can remove frames from my movie, and now it's a bit shorter again. So by that, I have now full control about how long I would be with the camera at a particular scene. I can then save the movie as before to file name. What I can also do is I can, at a particular position, for example, we have here scene number 4, we have here scene number 4, but maybe I want PyMol to move out a bit. I can do that here and click on Store. And then at that part, we want to look in that way, Store. Now let's play it again. We haven't changed something at the beginning. It interpolates to this scene. It moves out again, shows it from a different angle, and then moves in again. And by playing around with that, you can generate very nice and sophisticated movies with PyMol. That was a quick overview. If you go to the document website, you actually can get under tutorials a full tutorial about movie making, which has a few more tricks and tips. But I think the key things is generated from scenes, and with this freestyle one, you can adjust it as you like. Or you can start by generating a one based on scenes and then continue to modify your movie afterwards. Okay, I would like to show you a few more things in that session before your lunch is over. And they are not related to movies, so I will going to actually quit Pymol here, and I would like to start with a fresh session. We have a couple of nice plugins. For example, you can directly load PDB structures to Pymol by typing the command fetch and then the code for the PDB structure, or you can use under plugin the PDB loader service. That comes with every Pymol installation. There are many more plugins available on the wiki page. So whether you have found something you like on the Pymol wiki, a particular plugin, maybe not this one. You can just, I don't know which one is useful here. Just take anything. You basically copy the URL of that, and you can go to plugin manager, install new plugin, paste the URL here, and it will automatically download the Python files and installs it to Pymol. Anyway, that was just an excursus. I want to use the PDB loader service. I'm going to load a structure from the PDB, and I'm going to load a second structure, which is the same protein structure, just crystallized and having a different conformation. So I have these two identical ones, just different conformations. Now I can use under action align these two molecules based on their. Actually, I think I loaded the wrong. Sorry. I actually loaded the wrong structure. This is not the one I wanted to have. I'm sorry, my typo. Let me just going to get this deleted. And I'm going to for a key E and not AE key. Okay. So I'm going to align this to the other molecule. Okay. So we have aligned both of them. I'm going to show them as cartoon. So show as means show something in that particular representation and hide all of them, all the others simultaneously. So show cartoon would show cartoon in addition, show as cartoon shows only cartoon. You see, same structure, but they have a slightly different conformation in some areas and a large deviation in other areas. And what Pymol can do is it can generate a so-called morph, which is nothing scientifically telling you like a molecular dynamics simulation how something changes. It's just an illustration on what are the conformational differences. So if you go to A for action, generate morph to molecule 1, it will take a little bit of time because it interpolates the movements. Again, nothing correlated to a real MD simulation. It's just illustrating what has to change from one structure to get into the other structure. And it will generate an object here in our project, in our table, which has, in that case, 30 states. And as we have seen with the movie, we can then afterwards use the play button down here to show the changes. And I can show, for example, let's color that here in blue, and we see the two structures in addition. So we see we have the pink and the green one are the crystal structures, and the blue one is actually the morph, which is illustrating what has to change. I can have it here in Pymol, and I can also generate a movie from that. And that case, it's a structure with different states, like an NMR structure with different conformations. So you can go to movie program and do a state loop, and then you can control the speed, how long it should take, and how many seconds it stops at each state. So let's say half speed, 1 second pause. You see, it's a bit slower, and it pauses at the end for a second. and then you can save your movie from that. So it's related to movies, but we are also getting some kind of scientific annotation here to help us understand biomolecular structures a little bit better. Finally, let me just close that PyMol stuff again. We can also load a real MD trajectories in PyMol. PyMol understands Ember format, Desmond format, a Charm format. So I have, first of all, you load your the structure file, which has the connectivity in that case, a PDB file. And then in my case, I use the load underscore load trajectory command, and that will open the DCD file having the trajectory data. It takes a second, and then it loads all the different states in that object we had already. And now I can use the play button and see a real molecular dynamics trajectory here in PyMol. I have already deleted all water molecules before, just for the sake of clarity. You see, it's pretty fast. Probably that's not what you want. There are a few, and you also have like this translational and rotational movement of the whole structure. In order to get away with that, there are two useful commands. The first one is called intra fit. So if I apply that and specify a selection afterwards, and there's a powerful selection language on the command line, you can not only click that, but we can also, for example, say, I want to do a fit on all C alpha atoms. And to specify C alpha atoms, the atom name CA would be used. So if I do that, you see now I'm no longer having any rotation or translational motions, and I can much better analyze my dynamics. And the second useful for command is called smooth. If I type in that, also take a little bit. Now you see the movements are not so, the quick, we have basically interpolation, so it's better to see what is actually happening. And if you look at the trajectory, you see a couple of residues at the surface, or this one here actually in the center is moving a bit more. You can now visualize your data. You can also actually do measurements in PyMol. So we have a wizard measurements, and you can click a distance between two atoms. You see it's 5 angstrom. And if I now continue to play that, it automatically gets updated. You can see how that changes and what is going on. You can make a movie from that again, if you like. Movie, program, state loop, the same as with our generated morph before. We can use the trajectory. I have many more things I could show you. There are so many functions in PyMol. I have a few more ideas I could show you right now, but I would like to stop here and reserve the last 5 minutes for questions.
Great, thank you very much, Daniel. If anyone has questions, feel free to pass them on by chat. You can raise a flag, and if you're mic'd on your machine, I can unmute you. You can ask directly. And I can kick it off. One question that came in that I also had was, does the Axe PyMol work in the Mac version of PowerPoint?
Oh, that's a very good question, which I should have mentioned. Thanks for asking. So from our end, we have no problems in supporting MAP. The problem is that it uses ActiveX, and that's only available by Microsoft for Windows platforms. So they do not offer ActiveX plugins on Mac. Therefore, unfortunately, we cannot offer this plugin on Mac PowerPoint, and it can only be used on the Windows.
Okay. So anyone else, feel free to send me questions by chat. You can also, come on over. We also have a local group here, so
sure.
So I'll have them step up to the microphone. 1 second.
So I speak there.
Yeah.
Hello. Sorry, my voice a bit hoarse.
No problem. Yeah, sure.
Yeah. I also like use extensively PyMol, and I even have written the script for in the wiki that is deposited for the NMR constraints, to show the NMR constraints. But maybe it needs to be improved anyway. So I had a lot of difficulty, and I needed to write my own scripts to make movies for NMR structures that have individual states, and when I want to iterate between the different states for NMR structure, that's one thing. And I like your morph capability because it was not there before, so I had to use a script from Yale morphing depository or something, and then I made the morph. And
right,
then,
the morphing is something we haven't added so long ago in one of the recent versions. Before you had to hack it via a script. I agree. That is a significant improvement. But if you have an NMR structure, you can play these states here. Let's just simply think one NMR is actually an NMR structure. So if you see, if you load it into Pymol, it has 20 states. You can play, and you can generate a movie from these states if you like.
okay. Yeah, I know that, but for example, if I want to have different scenes and between the scenes to change the state, is it possible?
That's a very good question. Let me think.
I mean, because I do it with scripts, but anyway.
I think it is possible, but let's see. No. Actually, that's something I would have to look up. I will investigate that after the meeting, and I will send a response to Jason. I have his email address, and then he can forward to you. Would that be okay?
Yeah, sure. I mean, it's just maybe a request to put it as an upgrade if you don't already have it or something.
Yeah.
And
I think it may be possible, but let me check carefully after the meeting, and I will send something tomorrow or so.
yes, because for example, I wanted to combine the NMR constraint script that I have to make the NMR constraints, and then to be able to see the constraints in different states, how they deviate in different states, and some things like that. I know these are pretty much complex things, and Pymol is not meant to be used for calculating things about your structure, but I've been using scripts to do that.
Yeah, right. Yeah, it's totally fine. We can do. Yeah, many people have interest in doing more complicated things, so that's fine. I will have a look and send it to Jason, and if he can forward to you, that would be great.
Great. So one other thing, and we can wrap up on this. One of my favorite things about Pymol is that Pymol has this great logging feature that allows you to turn on the log and sort of do operations and then examine the log to see what sort of command line arguments you might need to redo that. I was wondering if you, for people who are maybe new to Pymol, if you could just show that really briefly.
Yeah, so if you go to settings and logging, you can turn that on here from 0, let's set it to 1. And now if I do something like zoom or orient, ray, whatever commands I did, it should, now the question is, I need to remember how I save the log actually. That's a good, yeah, oh, sorry. Okay, no, I don't do it over the settings. Go to file, log file, open, and let's just save it somewhere. Now I do again the commands orient, zoom, ray, whatever, and they should get automatically saved in this .pml file, which is nothing except a text file with all the logs. So you can interactively type commands, it will automatically get saved, and later on you have a Pymol script you can execute. So again, I go to file, log file, and then open, basically specify a name, and you can close it if you're done. And the next time you're in Pymol, you can simply execute any file ending .pml by typing, you can use @ but you can also simply type run, and then have it on the desktop, log, and it should should execute it. No, it's not responding. I think I know what happened. We are in an endless loop because
it's a really nice
PyMol is-
feature because it also translates the graphical clicks and the mouse clicks into the actual commands. So if you want to learn like one of the commands that you're doing, you can just do it in a menu or do it with your mouse, and then you can look in the log file and see what the actual command was, and then you can play those. It's very handy. I wish more software did that. So.
Right, and next time you want to do the same thing with another structure, you can simply repeat these actions. So again, file log, that's really useful. Thanks for reminding me. That's a good point. I should include that in the presentation.
It's a nicely unique thing to PyMol. Not very many programs do that. So great. Well, with that, it's 1 o'clock, so we'll wrap it up. Daniel, thank you very much.
To you. Yeah, I hope it was very useful to you. I'm happy to answer questions anytime you have afterwards. There are many more features one can discuss. So please feel free to reach out to Schrödinger, and maybe we have another session in the future.
Great. And thank you everyone for joining. Take care. Bye.
Goodbye.